Okay. Okay. First, let's look at canceling fractions. Let's say I give you the fraction 2 over 3. What could I times that by to cancel it out? Commonly called the reciprocal. That didn't show up at all. I can times that by 3 over 2. If you multiply that, you get 6 over 6, which is just 1. So basically the whole fraction went away. What if I give you the number 4, a whole number? What could I times that by to cancel it out? Now just using multiplication now, I don't want to divide, but I don't want it to be a 4, I just want it to be a 1. I could times that by 1 over 4, right, because 4 over 1 times 1 over 4, you get 4 over 4, which is just 1. Or how about this? What if I give you, I don't know, 2/5? And now I say, I just don't want that to be a fraction anymore. I want it to be a whole number. I don't want this 5 down here in the denominator. What could I times it by just to get rid of the 5? Leave the 2, but just get rid of the 5. I want to change 2/5 into 2 somehow. Brad, what do you think? If I times it by 1 over 5, 2 times 1 is 2, 5 times 5 is 25. 5 over 1? Or just 5? If I take this fraction and times it by 5, right, isn't that 5 over 1? The 5 up here will cancel with the 5 on the bottom. These cancel out, leaving just the 2. Or if you want to multiply it, 2 times 5 is 10 over 5. 10 divided by 5 is 2. Alright, this will cancel out the denominator here, leaving just a 2, leaving just a whole number. We're going to use these properties here of taking fractions, timesing them by something, and turning them into whole numbers to make our lives easier with equations with fractions. Let me show you what I mean. So let's say I give you an equation that's like 1 over 7x plus 3 over 7 equals 9. That is not a fun fraction by any means. Or not a fun equation. I don't like it. It's got fractions. I'm already scared. I already don't want to do it. But remember yesterday or the day before I said you can do whatever you want to an equation as long as you do it on both sides of the equation. Like if I want to, I could add 1 billion over here to this side of the equation. It'd be okay as long as you add 1 billion over here to the 9. I can do whatever I want. What I'm telling you is we can get rid of these fractions right away. If I was smart and I thought of a number that I could times everything over here by, that would cancel out those fractions. Like what could I times these by to cancel out the fractions? Could I do that? Should I times everything over here by 7? I also have to times the 9 by 7, but that's okay. Everything on the left I'm going to times by 7, and let's see what happens. So in the first term, I'm going to multiply by 7 times 1 over 7x plus 7 times 3 over 7 equals 7 times 9. I just times everything by 7, which is okay. You're allowed to do whatever you want to an equation as long as you do it everywhere. So now what's going to happen? I got these 3 terms. What are they going to turn into? Up in the front, 7 times 1 over 7. We'll that going to turn into? Yeah, 7 times 1 over 7 makes 1x, or we'll just put x. Right? Don't believe me? 7 times 1 is 7. 1 times 7 is 7. 7 over 7 is 1. What about the next term? Yeah. Over 49? 21 over 7? Right, because that's 7 over 1. You get 21 over 7, which is just 3. And then over here on the right, we get 7 times 9 is 63. Check out this equation. Isn't that much happier than that one we started off with? This one you can probably do in your head. All we did was we thought ahead and we're like, I don't want to deal with those fractions. Let me multiply everything by something so that my fractions turn into whole numbers. And this whole number over here just stayed a whole number. Now that it's like this, minus 3, x will equal 60. And this is what we're going to do. We're going to take equations with fractions and we're just going to get rid of the fractions so they become nice, normal, two-step equations. Let's see another one. Sometimes there's only one equation. I'm sorry, one equation. One fraction. I still don't want to really deal with it. So again here, 6x plus a third equals 2. We could minus a third and then divide by 6, but then you have a fraction dividing by a number. And I don't know. That's just weird. I want to deal with whole numbers. So I'm going to look ahead. Could I times everything here by some number to get rid of that fraction in the middle? What could I times it by? Anybody know any other number I could times it by? 6? 6 would work. What else could I times it by? What is it? Would 2 cancel out with that 3? We could do 3, 6, 9. What else? 12, 15. Anything that over here could be divided by this 3 to cancel it out. Alright, so we just happen to be picking the smallest number. So I'll times everything by 3. The 6x times by 3 plus 3 times the 1/3 equals 3 times the 2. So take a second to think, well, what's this going to turn into? Okay, Leah, what's the first one? What's the first part going to be? Plus 3 times 1 over 3. The 3 times 1 is 3. 1 times 3 is 3. It's just 3 over 3, or just 1. Or it doesn't go away, it just turns into a 1. Equals 3 times 2 makes 6. So now I have the equation 18x plus 1 equals 6. All whole numbers. Now I can do my 2 steps. First step, minus 1. Cancel that with positive 1. So 18x equals 5. And then what's the last step? How do I get rid of the 18? Yeah, right. Divide by 18. Can you divide 5 by 18? Yeah, but I don't want a decimal. If I can't divide it, just leave it. It's called a fraction. 5 over 18. See, I didn't have to deal with the fraction until the very last step when I just wrote down what I wrote down. Right here. So by taking this first step, we're getting rid of a fraction. Some of you might be freaking out about why am I timesing everything here by 3? Shouldn't I just times this by 3 and this by 3? Well, what we're doing is we're timesing everything on the left by 3 and everything on the right by 3. And when you do that, this 3 gets distributed to the 6x and the 1/3. I'm just skipping that so I don't have to. So I'm not confusing you any more than I have to. You can pick any number in the world to multiply this by, but we're picking ones that will cancel out the fraction. I could have times by 7, it just wouldn't have helped me. Okay, one last one. I'm flipping to another page because I ran out of room. So we got to be clever with the numbers that we pick. We can't just pick any number. And some numbers work, but I don't want to have to keep doing this over and over again. I want to just do it all one shot so then I can do my 2 steps. So there's the last one. 3/4 x plus 1/2 equals 1/8. Again, I don't want to have to deal with converting, multiplying, dividing fractions when I could just take one step and change them all into whole numbers and not have to worry about it. So here, we've got to be careful, because you can multiply by all sorts of stuff. But I want to multiply by a number that will cancel out all of those fractions in one shot. For instance, you guys could pick 2. The 2 will cancel out with this 2 here, but if I multiply this first one by 2, the 2 will not cancel out with a 4. Right, I'll just end up with 6/4, which is still a fraction. And same for the 8th. It won't cancel out. I need a number that will cancel all of them out at once. This is where you guys think of least common multiples, common denominators. Whatever number that is, it'll work. Sam, what did you say? 16? Anybody think of a different number? There's lots of numbers. Caitlin, what do you think? 8. There are literally infinity answers to my question. So you got 8, 16. Will 4 work? Can a 4 cancel out an 8? No, 4 won't work. So I got 8, 16. What else? 32 would work. 24. Slush, you want to give me another one? 2. Any number that can be divided by 4, 2, and 8 is 16, 8. We'll pick 8, because I like using the smallest one. 16 would work too, but I just want to use the smallest one possible. Yeah. Wait, what? Yeah. Oh, okay, who? Who's her, right? You? Yeah. Okay. Yeah. Awesome. Virtual high five. All right. So everything here I'm going to times by 8. So it's going to be 8 times 3/4 x plus 8 times 1/2 equals 8 times 1/8. Remember, we could have picked all sorts of numbers. We're picking 8 because it'll work for all of them, and it also happens to be the smallest one that'll work. So I'm going to give you like a minute. Try this on your own. See if you can figure out what will this turn into after you times them by 8. Just try it. Remember, if you screw it up, I'm going to tell you in a minute anyway. Okay, I'm going to do this. I'm going to throw down with the extra step here while you guys are still going. Remember, these are all 8/1s. And if I was just to times them regular style straight across, 8 times 3 is 24. 1 times 4 is 4, so it's 24/4x plus 8 times 1 over 1 times 2 equals 8 times 1 over 8 times 8. 8 times 1, I mean. But all those are whole numbers. So somebody tell me what's the equation after you multiply? What do you get, Alex? A much happier equation than what we started with. Whole numbers, they're small, they've probably got other redeeming values. Yeah. So in the beginning, how about if you multiply straight across? 8 times 3 is 24, 1 times 4 is 4. Are we good with that? 24 over 4x? What is 24 over 4? 24 divided by 4? Yeah. We good? Okay. So now what are my 2 steps to solve? Yes. Let's subtract 4. So I get 6x equals negative 3. Final step. Divide by 6. Can you divide 3 by 6? No, so it's just a fraction, but you could probably simplify it. What's 3 over 6? Negative 3 over 6. Simplified, you can. Negative 1/2. I like not having to deal with fractions until the very last step.